Why do Kubernetes nodes and pods sometimes take far longer to start than they should? Today on KubeFM, we're joined by Jan. In this episode, Jan walks us through a real optimization effort focused on node and pod startup performance across large EKS clusters running at scale. We look at what actually drives startup latency, image pulling behavior, EBS throughput limits, and why defaults like serial image pulls quietly slow clusters down. Jan explains the changes that made a measurable difference, including parallel image pulls, selective image caching, and automated throughput tuning to balance performance and cost. This episode of KubeFM is sponsored by LearnCube. Since 2017, LearnCube has helped Kubernetes engineers from all over the world level up through Kubernetes courses. Courses are instructor-led and are 60% practical and 40% theoretical. Students have access to course materials for the rest of their lives. They are given in person and online, to groups as well as to individuals. For more information about how you can level up, go to learncube.com. Now, let's get into the episode with Jan.
You're tuned in to KubeFM.
Welcome to KubeFM. What three emerging Kubernetes tools are you keeping an eye on?
Okay, so one of them is sidecarless service meshes. I think those are great technologies. The other one is Bottlerocket, which we recently implemented, and I really like the concept and how it works, having only what you need for running containers. And the third one is Carpenter. I always like the auto scaling and the concepts behind it. So we also started using that recently, and that would be the third one.
Okay, great. And for people who don't know you, can you tell us about what you do and where you work?
Yep, so I work at Outreach. We are a revenue workflow platform, which is targeted for basically seller customers. I'm site reliability engineer here for 4.5 years, and we use mostly AWS, Kubernetes, Terraform, and also observability stack.
And how did you get into cloud native?
Okay, so I started as a network engineer, and then I moved into consulting a little bit, but infrastructure consulting. So I worked in on-premise data centers, and I really liked AWS. I switched to some AWS projects while I was in consulting, and after that I switched career paths into a cloud native and engineering.
Okay. And you mentioned this a little bit, but what were you before cloud native?
Yep. So I have a degree in telecommunications, and I was first a Cisco network engineer. So I worked all the switches and routers. So then I moved to the very different set of technologies in on-premise data centers, but I didn't stay there for a long time because I really liked AWS or cloud, which I chose AWS from all the main competitors. And I moved to engineering career path. I worked at AWS at first, so it was easier for me. It was easier to get into, and I started picking up more and more the additional technologies that you need for current infrastructure. So Kubernetes and Kubernetes is the main one, and Terraform and the other the usual stack.
Okay. And how do you keep up to date with the Kubernetes and cloud native ecosystem? Things move very quickly. What resources work best for you?
Well, recently I started using AI or LLMs because I think they work well as a, let's say, better browse engines or browsers, search engines. So I use those trying to find what other people are using, and I'm hoping it will give me it will go through all the resources that I don't have time to go through. But I also try to read information in various Slack channels like Kubernetes Slack, Istio Slack, and a couple more. And also when I'm working on something, I'm trying to read let's say GitHub issues or some relevant GitHub issues on some projects that I'm currently using, and sometimes I'm just finding some things that other people are using, and I'm reading on those, and I go from there.
And if you had to go back in time and give yourself one piece of career advice, what would it be?
Yeah, probably that consulting is not for me. Like, I think it's a very specific world, and I found myself much better in engineering.
Now, as part of our monthly content discovery, we found an article that you wrote titled Optimizing Node and Pod Startup Performance. So we want to dig into this topic a little bit further. Let's start with some context about Outreach and your infrastructure setup. Can you tell us about the platform and the scale you're operating at?
Yep. So mostly we are on AWS. We have around, I think, like 10 production clusters running somewhere near like 1,000 bigger nodes. We use EKS. We are on 132 at the moment. We recently moved to Bottlerocket, as I mentioned, and we use Carpenter as our auto-scaling tool. So that's like the high level.
And many teams struggle with slow Kubernetes node and pod startup times. What specific pain points were you seeing that prompted this optimization effort?
So this was more like my own project. It wasn't driven from the top, like from the business. But my thinking was that like if our customers need to perform some tasks in our platform, in our product, like every second we can get rid of our node or pod startup times is beneficial for them because they will see better performance. So this was like the main theoretical idea. I actually don't have any. I wasn't able to find any metrics, internal metrics for like our platform latency, but this was the main thing. My other reason was that AWS bills resources like per second. So I was thinking like if we get every second, we don't need to have these nodes available or online, and we don't have to pay for them. We can save money by not paying for them. And that was the third reason.
Now, before diving into improvements, measuring performance is crucial. What metrics and tools did you use to understand your baseline startup times?
So before I started, I realized I really don't have any a good sources of information about how our nodes how long they are starting. So I found after some research, because it's not that well documented, that Kubelet exposes metrics for pod startups, node startups, and image pools. And also there is a one under solution, and Carpenter has kind of like the same metric for pod startups. So I used Kubelet's metrics port to get the metrics.
Kubelet logs seem to provide particularly detailed information. What insights can teams gain from analyzing these logs that they might miss from metrics alone?
Kubelet has the information on every pod, and it records information about when the pod started, when it started pulling image, and when it was fully running. So you can find a very detailed information on each pod, but these are not available easily in metrics because the cardinality would be very high. So if you are able to get all the logs out and somehow parse them, get metrics from them, that would be a valuable source of information. There is also information in the logs that's called pod start SLO duration and pod start end-to-end duration, and that means that pod start end-to-end duration is like is a full pod startup, and SLO duration is the same, but it doesn't include the image pool. So it could be useful for developers that can't really influence how long pod image is pulled, but they want to work on optimizing their pod startup time from like the runtime perspective.
Got it. So image caching in AMIs is a common optimization strategy. You discovered an interesting problem with EBS lazy loading. Can you explain what happened with your other 900 megabyte image?
Yeah, so my first thought was that we will just pull the biggest image that we have, that we use, and we will just save like 20 to 25 seconds from the pod startup if we don't have to pull it. But when I did this, I often found in the logs that I mentioned before that this actually didn't help, and the bot was still pulling the image as before. So I was doing some research on this, and I found some information that sometimes the EBS might not have the data when you need it because it's lazily loaded like on the background, and only will start requesting data when you actually ask for it. So I realized that this might not help. Like this will not be the solution to get the 25 seconds of the bot startup.
So after the EBS lazy loading issue, you pivoted to a critical path strategy. What images did you focus on, and why did this approach work better?
Yep. So I thought that if I can't get the biggest image to be cached successfully, I wanted to try pulling and caching smaller images. So images for daemon sets like uproxy, VPC images, and node local DNS that we are using. So I cached that into the image, and actually that seemed much better. And we saw on average like a 10-second reduction in bot startup times.
Kubernetes pulls container images serially by default, which can create bottlenecks. How did you configure parallel image pulls, and what should teams watch out for?
So one of my biggest surprises was that Kubelet by default pulls the images serially. So the default setting is to not pull them in parallel. So there's a flag called serialized image pulls, and you have to set it to false. Otherwise, it's by default true. And there's also setting to limit the maximum number of images being pulled in parallel. And you can just set whatever you want to make sure that the nodes are not overloaded by too many images being pulled at the same time. So, for example, this image is useful if you have one huge image. The kubelet will start pulling it first, and then there might be 10 other tiny images in queue, but they will have to wait. So for this situation, this setting can help. And it also helped us with reducing the image times, node startup times, because I didn't look into detail into this, but I can imagine that there was a big image that came from Kubernetes before some other smaller images that were needed to finish the node boot, and they slow down the node startup time.
EBS volume throughput limits can significantly impact startup performance. Can you walk us through your analysis and the throughput levels you tested?
So by default, we use GP3s, EBS volumes, and they have 125 megabytes per second throughput. So I tried setting this higher, and it actually has a good impact on node boot times, pod startup times. It also affects some other things like extracting images that are being pulled. So at first I tried setting it to 300 megabytes per second. That helped a lot. So I thought like, how far can I go? So I tried setting it to even I think 1000, but I saw that it didn't help. Such a higher value didn't help as much. So I went down a little bit. In the end I ended up at 600 megabytes per second. The reason also for that was that when you look through like the instances and their throughput limits, so each instance has some limit that it can handle, and usually like 600 megabytes per second seemed like the sweet spot for most of the instances that we use. So this might be a higher number for someone who's using like the biggest instances. It might be a lower number for someone who's using smaller instances.
Increasing EBS throughput adds cost, but you only need it during startup. Can you explain the automated solution you built to optimize this?
Each time the instance is started, it will there's an event in CloudWatch, Event Bridge, which is now it's called Event Bridge, and the event records that the instance was started. So I built a small solution that the event will trigger. It will go through SQSQ, and then it will go to Lambda, where where Lambda actually changes the EBS throughput back to their original value, basically the one that's like the free one, but I mean the same one which is in the default configuration of the volume.
The automation system using CloudWatch, SQS, and Lambda is elegant. What were the key implementation details that made this work reliably?
Yep. So one of them is SQS delay queue. So I was trying to find out how to delay the message for several minutes because I wanted to give the instance some time to stabilize, let all the pods start. So I settled at 10 minutes, and SQS queue can delay the messages by, I think, maximum to 12 minutes, maybe 15. But I think we are right now at 10 minutes. So the message is delayed, and after that it's sent to Lambda as a trigger, and Lambda uses some tags to filter down to basically check the instance that emitted this start event is the one that should be modified, and if all the tags are correct, it will go to the volume and modify the EBS volume, which can be done without any interruption to the volume itself or to the instance itself. However, this is true in our case. Maybe for someone who's using some has some really like a latency sensitive volumes, this might not be completely true, but I can't really talk about it because in our environment this is fine.
Okay. And let's talk about the actual results. What improvements did you see across your various metrics after implementing all these optimizations?
On average, the node startup was improved by 20 seconds, so we went from 65 to 45 seconds. It also helped with the P90 for pods, so the P90 was reduced by roughly 30 seconds, from 80 seconds to 50 seconds, and also like the average pod startup time was improved by like 10 to 15 seconds. So the biggest effect was on the Kubelet node startup iteration seconds metric, which is the full node startup. And we also saw improvements in image pools. And that's all.
Okay. Performance improvements often come with trade-offs. What limitations or considerations should teams be aware of when implementing these optimizations?
Yeah, so as I said, I think one of them would be possible like negative effects on the EBS volume, which I can't really say if and what they are. As I said, not really a concern in our case, but for someone else it might be visible. There might be some visible like performance degradation while the volume modification is in flight. There's also the added cost for the increased throughput, which with the Lambda that we talked about is not as high. In our case, it's acceptable for the result it delivers. And actually, right now the biggest problem, not a problem, but it added overhead to our team where we need to match the contents of the image or the image snapshot. Like the images need to match the images that we deploy on the cluster. We right now don't have automated solution for getting the same image inside the AMI or the snapshot. So this is a little bit like operation overhead for us right now.
And for teams out there that are running similar EKS setups with Carpenter, which optimization would you recommend starting with for the biggest impact?
It seems like the switch enabling the parallel pulling is the best way to go, since it's just like one flag, and then you can, if you want, you can tune the maximum images being pulled in parallel. But this is like the easiest way how to get things better or start pods faster. This will not help with the node startup that much, but I think in the end we care more about the service pods and application pods over the nodes.
And looking back at this optimization journey, what surprised you most, or what lessons learned would you share with other infrastructure teams?
So what surprised me the most was that the images are not pulled in parallel. They are pulled in a serial way, and that's the default setting in Kubelet. And you have to actually go and change it to be parallel. The other thing was that actually the kubelet will not prioritize the pods in any way, as I found. It seems like basically the only way how to control what the kubelet will pull and start is by time when it's recorded in Kubelet, or by the time it comes to Kubelet. So that was those two things were the biggest surprises.
What's next for you?
Right now we are in progress of working on the ambient service mesh. So that's a really difficult topic, I would say. It's very complicated, but at the same time very amazing technology. I'm still surprised how great it is, but also terrified by how complicated it is. So I'm looking into adding Argo workflows tool into our tool stack, because it sounds really interesting for things like running one-off scripts, doing some tasks that need to be done and not running them from our own laptops. And on the other hand, easier than just writing some arbitrary pods for each task. So it just seems like a very consistent way to do things.
Okay. And if people want to get in touch with you, what's the best way to do that?
I think the best way is through LinkedIn. I'm usually there reading all the updates.
Great. Well, thanks so much for sharing your experience with us today. Look forward to interacting with you in the future. Take care.
Thank you.
You're tuned in to KubeFM.